Hey everyone, welcome back to GradeGetter. My name is Taylor, and today we are continuing our series where we work through a practice test for the ACT. This series is designed to go through an entire math test so that you know what kind of questions will be on the test and how to study for them. Alright, let's make the ACT make sense. In part 1 of this series, we introduced the ACT math test, and we actually worked through the first 3 problems of the practice test together. And so we're going to do the same process in our video today. We are taking our time working through these questions so that you know the concepts of these problems and how to solve them. Today we are picking up where we left off from our last video. Alright, here we go. Question number 4. Hallie is bowling a series of 3 games. She has bowled 2 of 3 games with scores of 148 and 176. The figure below is a top view of the bowling lane. The dimensions for the bowling lane are given in the figure. The pin deck is the rectangular area within the bowling lane where the 10 bowling pins are set up. So this area right here is the pin deck. So this is the information we're given. And then we're finally told or given a problem to solve. So you're probably going to have a couple of problems in a row that all relate to this data here, but just have different questions or problems to solve here. So let's see what we need to find out, what they're asking. So it says that the diameter of each pin at its base is 2.25 inches. When all the pins are set up, which of the following values is closest to the area in square inches that is covered by the bases of the pins? So that is what we're trying to find. Next, let's write down what we're given to help us solve this problem. So from this question, it says that the diameter of each pin is 2.25 inches. So I'm going to write that down. And then up here, in this information, we're told that there are 10 bowling pins. So that also is going to help us solve this problem. So I'm going to write that down. Now, if you're new to my videos, I really like to use the find given technique for problem solving, especially for word problems where you have a bunch of information kind of thrown at you, and you literally write down what you're supposed to find and write down what you're given. Now, this feels like it takes up a lot of time. So 2 things to think about that. First of all, it does take some time, like I'll be honest. However, in the long run, I think it may save some time in trying to sift through and work through, okay, what am I even trying to find, and what information can help me find what I'm looking for. And that's where using the find given kind of helps you give a method or a process for solving problems. Secondly, you don't have to do this exactly like how I'm doing it. I always advise students when they're starting out to write down what you're supposed to find. That really doesn't take that much time, and it gives you focus on what you're looking for. However, you don't necessarily have to write down, you know, the word given and then all the stuff that they give you. You know, instead of writing the word diameter out, I could have just wrote D equals 2.25. Right, that's just kind of used shorthand. So you don't have to do it exactly like how I'm doing it. However, if you really struggle with some of this stuff, it can be a helpful way to get better at problem solving. And then as you get more skilled and efficient, you can kind of dial back on some of these steps. But I like to solve these problems in a more slow way so that you see how I'm solving it, and so also you kind of know how to study for yourself in the future. So the area for one of the bases of these pins is going to be the area of a circle, right? That's the area that it makes in contact with the pin deck. So I need to find what the area of a circle is. So the equation for that, area equals pi times the radius of the circle squared. So if we knew the radius of one of these bowling pins, or the base of the bowling pin, then we could find the area of it. Well, obviously aren't given the radius exactly, but we are told the diameter. And the radius is just the diameter over 2, right? If this is our circle, the line that goes through the middle all the way across is the diameter, and the radius is half of that line. It starts at the center and goes to the outer edge. So that's the radius. So we'll just take our diameter and divide it by 2. I'm going to bring up our calculator to do that. 2.25 divided by 2 is 1.125. So that's my radius. And now I'll plug that value into my area equation. So we have area equals pi times 1.125 squared. Now this square is only attached to the radius. So I'm only squaring the radius. I am not squaring pi. So I'm going to simplify this now. I'm going to keep my pi, and now I need to figure out what 1.125 squared is. So I'm going to bring up my calculator again, type in 1.125 and square it, and then I get this answer, 1.265625. So I'm going to write that down. Now at this time I'm going to go ahead and start looking at my answers. Sometimes the answers will be in terms of pi, which means it's just going to have pi attached to your number, right? Like it's multiplying. However, I don't see any of these with pi in them, so that means I'm going to have to probably multiply this out. I'm going to have to multiply pi times 1.265625. So let's go ahead and do that. Now, a lot of your calculators will actually have a pi function on them. I'm just using a very basic calculator application on my computer, so I don't have an actual pi to type in. So I'm just going to multiply it by 3.14 as an estimate for pi, approximation, and let's see what we get. So I get 3.974. So I'm going to say that the area for one pin, for the base of one pin, is approximately 3.974, right? That's the squiggly little equal sign, means approximate. So again, we've got to think this is just the area for one pin, but we have a total of 10 bowling pins. So now I'm going to multiply this by 10. So to do that, I would just move, you can type that in a calculator, but you can do that in your head as well. You just move the decimal place one place to the right. So for all 10 pins, this will be the area for one. Area for all 10 is going to be 39.74. Now again, we come over, look at our potential answers here, and it says, which of the following is closest to the area? And so it seems that A is our obvious answer. That is the closest area for the base of our 10 bowling pins. We've got a couple more problems to solve, but before we move on, I just wanted to let you know that GradeGetter offers a whole series of videos that focus on the math portion for the ACT. So if you're looking for helpful tips to boost your score, then be sure to like this video and head over to our website at GradeGetter.com. We are here to help you get the grade you want and to make the ACT make sense. Now back to the video. Alright, question number 5 is actually related to question number 4, and that we're working with the same data. Right, the same information here, same picture, so I'm not going to reread that. However, we are given a new problem to solve here, which specifically asks, what is the ratio of the total area of the bowling lane to the area of the pin deck? So that's what we're going to find. I'm going to write that down. So we're looking for a ratio. Now let's write down what we are given. Well, we're trying to solve for the ratio of areas, and we aren't given the explicit areas for the bowling lane or the pin deck, but we are given some dimensions from our picture here, so that we can actually figure that out. So I'm not going to redraw that or rewrite those out. We are going to find the total area of the bowling lane and the total area of the pin deck. So the area of the bowling lane is going to be the 65 feet times, that's the length, times its width, 3.5 feet. Now, I thought about maybe not including the pin deck here, the dimension of the pin deck here, but I think it's also considered part of the bowling lane. And so I'm going to take into account this whole 65 feet, which includes the pin deck. But like I said, we'll also figure out what the area of the pin deck is as well. So we're going to multiply length times width, so 65 feet times 3.5 feet, or 3.5 feet. And I'm going to type that into our calculator here. So 65 times 3.5 is 227 point, what was it? 0.5. 227.5 feet squared. Next, let's figure out the area of the pin deck. So the dimensions of the pin deck is it's 5 feet long, but has the same width as the entire bowling lane. So it's going to be 5 feet times 3.5 feet. And we'll type that into our calculator as well. So 5 times 3.5 is 17.5. So that's the area of our pin deck. Now let's create a ratio comparing the area of the pin deck to the area of the bowling lane. Now there's a couple of different ways to write a ratio. You can write it with a colon in the middle of the things that you're comparing, or you can also write it as a fraction like this, where one of the dimensions or the things that you're comparing is placed over the other. So I think I'm going to see if we could simplify this. So I'm going to actually write it as a fraction. I'm going to write 227.5 over 17.5 and see if we can simplify this. So one simple way to simplify would be to see if 227.5 can go into 17.5. So I'm going to divide it by, and it does. So 227.5 divided by 17.5 is actually 13, or 13 over 1. So although J looks really tempting, right, because it's really close, these numbers are missing the 0.5. So to me that was kind of a warning sign, like maybe there's more going on here, because it's not exactly right. So I decided to see if 17.5 was maybe a factor of 227.5, and sure enough it is, because 17.5 times 13 is 227.5. So the simplified ratio is 13:1 of the bowling lane to the area of the pin deck. Question number 6 is also related to the previous two questions of number 4 and number 5, because we have the same information, same picture here, but again we've got a new problem to solve. So it says, what score will Hallie need to earn in her third game to have an average score of 172 for the 3 total games? So that's what we're trying to solve. So I want to find what she needs to score in her third game to have an average of 172. So next let's write down what we are given. Well, this picture here just gives the dimensions of the bowling lane. Has nothing really to do with her scores, so I can kind of just not focus on that. Instead, I want to focus on the scores of her first 2 games. So she scored 148 and 176 on her first 2 games. So I'm going to write that down. And I think this is really all the information we need to solve this problem, because to find the average, we're going to sum up all of the scores together and then divide by the total amount or number of scores that there are. So this is what our equation is going to look like when we set it up. So I'm going to add 148 and 176, which are the scores from her first 2 games, and then I'm trying to find out what she needs to score on her third game. So we'll just call that score X, because we don't know what it is. And then we're going to divide by the total number of scores. There are 3 total scores, and this will be our average. Well, we're given that the average is 172, so this should equal 172. Now we have a simple algebraic problem where we're solving for a variable. So let's go ahead and do that. I'm going to get this 3 out of the denominator by multiplying both sides by 3 in the numerator. So 3 over 1. These 3's cancel out, and I'm left with 148 plus 176 plus x equals 172 times 3. So let's see what that is, which is 516. I'm going to add 148 and 176 now. Use my calculator for that. 148 plus 176 is 324. So 324 plus x equals 516. Now we'll subtract 324 from both sides. Right? We're trying to isolate our variable. We're trying to get x all by itself. So 516 minus 324 is 192. So these cancel out and x equals 192. We have solved for our variable, which is our unknown score that she needs for her third game to have an average of 172. So D is our correct answer. Alright, well, you've just solved several more problems from the ACT math test. We're going to keep chipping away at these problems, so make sure you watch the next video in the series and subscribe to the channel so you stay updated on all of our content. If you want access to more videos, then check out our website at GradeGetter.com. Thanks for watching, and until next time, God bless.